So in this video, I'm going to show you guys how to do some of the basic statistics for this pill bug lab. So I have here a fake set of data. Your data will look different from mine, so do not copy mine. If you do, then I know that you didn't do it yourself. So make sure that you do not copy mine because it is in no way the real set of data. So what I'm going to do is I have here my TI-30XS. And if you do not have a TI calculator, I recommend using a TI versus Casio or another model. This TI-30XS is similar to the TI-84, but some small things are different. And if need be, I can show you guys how to use the TI-84 in another video or in an SLS event. So what we're going to do is we're going to take our two sets of data. So we have from 0 minutes to 10 minutes for wet and for dry. So we're going to input both of these sets of data in the calculator. So if I put the calculator on the big screen so you can see it a little bit better, we have here data. This button here says data. Maybe you'll have to zoom in on it and see. And in green right above it, it says stat. So what we're going to do is we're going to press data first, and it brings up these three columns. These three columns are we're going to input our data in these columns. Now we're going to use two columns because we have two sets of data. So this says L1 and this says L2. So let me see if I can zoom in on that. Okay, so maybe you can see here where you see L1 and L2, and then there's also an L3 if we had a third set of data. And we can use our little controls here to navigate to the other columns. So we're going to start in L1. So we're going to put our first set of data. Now it doesn't matter which set you put where, but just remember which set goes with wet conditions or dry conditions. There's no indication on the calculator to remind you. If it helps keep things clear for you, then only insert one set of data at a time. So now what I'm going to do is I'm going to start inserting my data. All right, so the first number is 8 for 0 minutes. So I'm going to press 8, I'm going to hit enter, and then you see it puts it in as the first number in the L1 column. And then next we have 9, enter, then we have 10, enter, and so on. Okay, and now fast forward, I have all sets of data in the first column. Now, a quick way to check yourself to make sure, if you count, you should have 11 sets of data. So our sample size for the first column is 11. From 0 to 10 is 11. So go back up and count. So it's 1, 2, 3, 4, 11. All right. So now I'm going to navigate over right to the next column, and I'm going to insert my data for dry conditions. There we go. I've got that in there. Now the next thing we're going to want to go to is this green stat button right above the data button. Now, if you're using a TI-84 or another type of calculator, your button will be somewhere else. So I'm going to hit second and then hit the data button, which will actually be hitting the stat button. Notice the color coordination between the green second and then the green stat. So hit that and brings up stats, 1 var stat and 2 var stats. So this basically would allow you to look at either one set of data at a time or two sets of data at a time. So we're just going to look at one set of data at a time. Okay, so we're going to hit enter for 1 var stats. Now this calculator gives us the option of selecting which data set we want to look at. So we're going to look at L1 data, our wet chamber data first. So I'm going to hit enter, and then for frequency we're always going to do 1, enter, and here it says calculate. There's a glare. See, it says calculate. So enter again, and there we go. There's all of the data that I'm going to need for this lab. So in I wonder what N stands for. Well, if we refer back to our notes, so on page 11 of our student notes, it talks about the data analysis and statistics. So this is where you get to that step of the scientific method where you're analyzing your data. You're analyzing your data now like you've never analyzed your data before, I guarantee you. So here it says, there's that N that we were looking at. So that says sample size. So literally means how many sets of numbers do we have. So from 0 to 10 minutes, we have 11 numbers. So our sample size is 11. And that's what it says right there, 11. The next, for number 2 there, again, your calculator may look different. We have X bar. We have an X with a bar, a horizontal bar over the top of it. So what does that mean? The mean right here, also on page 11. It has the average or the mean is X bar, sample size is N, standard deviation is S, standard error is SE sub X. Each is important. So the mean is the average. All right, so this calculates the mean for us very quickly and easily, much easier than inputting each number individually and doing that twice for both sets of data. Now the next number is important, is the SX. So what did the capital S stand for? Right, stood for standard deviation, capital S, you see right here. So that's what we're looking for. Now there is another number below that. If we go down, this number for 4, that is sigma X. That is a Greek symbol. That is not an O or a 0. It is sigma X. That is also standard deviation, but it is a different standard deviation. Both basically do the same thing, but they do that for 2 different sets of data. So ours is a sample set, so we're going to go with sample standard deviation. This one actually stands for population standard deviation. But we're not looking at a population, we're looking at a set of data. So this is the number that you're going to use, that you're going to input into your lab sheet. All right, so now we can almost complete our worksheet. So our sum, now I don't have to go through and add these all up again, the calculator does it for me. If I go down, it says sigma X. Sigma X, that stands for sum. So I'm going to hit my text box, I'm going to insert, it says 113. So if you add all these numbers up, for me it is 113. And then we go to the mean. So it also tells us what the mean is. So I'm going to go back up to the mean. It is 10.27. So we're going to round to the nearest significant digit. So we're going to round to 2 decimal place basically. 10.27. Okay. And now the standard deviation. So think for a second, are we going to use this one or this one? Let me make that big screen. We're going to use this standard deviation or this standard deviation. Remember, they're both standard deviation, but one applies to us and the other does not. If you guessed this, SX, then that's correct. That's the one we're going to use. So we're going to use the SX, the sample standard deviation, not the population. So it says 2.9695. So we're going to round to 2 decimal places. So that's going to be 2.97. Okay, so we're going to come over to the other column and do the same thing again. We do not have the standard error of the mean just yet, but I'll show you how to do that in just a second. So now we need the sum for the other set of data. So we're going to go back. We're going to hit second, stat. We're going to go 1var stats again. And so this time we're going to come over to L2. I'm sorry, let me make that big screen. Okay, so we went to second stat, and we went one var stats, and now we're going to go to L2 for our data, because we're going to use our second set of data, frequency 1 again, and calculate. And there we go. Again, we have a sample size of 11. We have a mean of 5.73, and then we have a standard error of 2.97. So our standard, I'm sorry, I said standard error of the mean, our standard deviations. So our standard deviations are the same, and we're going to talk about what standard deviations mean. But right now we're just going to input that data. Also, our sum down here is 63. Mean is 5.73. 5.73. And then standard deviation, using the big SX, not the other one, 2.97. All right, so the next thing I want to do is I want to talk about these numbers. Now, sum is obvious. It's the total of all of these numbers. But mean and average, what does a mean or an average actually represent? Well, it gives you one number that represents all the numbers that you entered. So one number that is as close to all the numbers as possible. Now, a little side note, in science, in statistics, the average or the mean can be misleading because, as you see for our first set of data, 10.27 is our mean. But you have extreme values called outliers, and this is not important for you to know, 15 and 8. So if I'm looking at 10.27, I may not realize that some of the sets of data were actually very far from my mean value. So that's the average. Now, the standard deviation, think about the wordage, standard deviation. Think about what it means to deviate from the standard. What is the standard? Well, in this case, the standard is our average, our mean, which here is 10.27. And our standard deviation is 2.97. So basically what that means is that all of our numbers deviate from the mean by 2.97. It explains in your note. It says on your notes on page 11, down towards the bottom, it talks about standard deviation and standard error. So standard deviation says here's a tool for measuring the spread variance in the sample population. Down here, which in turn provides an estimate of the variation of the entire sample set. A large sample standard deviation indicates that the data have a lot of variability, and a small standard deviation indicates that the data are close to the sample mean. So let's take a look at our sample means. So if we look at our numbers, or the numbers that I have here, the standard deviation is the same for both. So even though we had two different means, which is the sort of the central number for all of our sets of data, relatively based on the standard deviations, if we compare the two, then all of our numbers stayed fairly close together and are not scattered all over the place. So if we had like a crazy high number here, then maybe our standard deviation would greatly increase. Or if we had 8 here, and then we had 16, and then suddenly 1, and then 2, and then suddenly 15, if our numbers just go all over the place, our standard deviation will be higher because our numbers are deviating very highly from what the mean would be. All right, so that is standard deviation, and I'm going to have to do a separate video to explain how to calculate standard error of the mean.